Welcome to 6.1 video notes on polynomials. Okay, I'm going to talk quickly just about some vocabulary about polynomials, starting with the left side here. For all of these, okay, I'm just going, well, we'll see here in a second, but I'm just going to write expression at the top. All of these are just different ways to describe expressions with and then colon. A monomial is an expression with one term. Okay, the binomial is an expression with two terms. The trinomial is three terms. And then polynomial usually means four or more terms. That's like 4 plus. 4 plus terms, 4 or more. Okay. On the other side, the degree of a polynomial is a little different. Yeah, the degree of a polynomial is just the number, the powers added. Okay, whatever that number is all the powers added. Exponents added. Sum of the exponents. Sum of exponents. If you want to write that, you can write that as well. Okay, the leading coefficient on a term is just number. It's multiplied by the variables. Okay. The degree of a polynomial, remember that's more than one term. Okay, if as many as 4 or more, if you have 100 terms in a polynomial, okay, that's going to be the largest, how do you say this? The degree is the term that has the largest degree. So the degree of a polynomial is whatever the term with the largest degree is. Okay, so I'm just going to say largest degree. Okay, so whichever term has the biggest degree, that is also the degree of the polynomial. And a polynomial function, that's just a function that has a polynomial on one side of the equal sign or in its expression. I'm not going to write that. I think that makes sense. So like f of x equals and then a polynomial. Okay, moving on. You scroll down. You can see on the right side, classifying by number of terms. Okay, we just kind of talked about that. In this chart, just to explain it, there are 5 different types of polynomials in the chart, and that with an example for each. Okay, so if we look at the linear one with a degree 1, okay, that is just an x with x to the 1. Okay, degree 2 is just the polynomial where its largest degree is 2. Okay, the largest variable is 2. Excuse me, largest exponent is 2. Cubic has the largest degree of 3 among its terms. Quartic 4 and quintic. Okay, largest degree is a 5. The interesting one is largest the constant with degree 0. Okay, because it's negative 9. It's kind of like having an x to the 0 there, a 0th degree. Anything raised to 0 is just 1. So if that's just 1, we can get rid of it. Negative 9 times 1 is still negative 9. So we just don't write that. So anytime you see a number without a variable there, that's actually a degree 0 term. Let's practice a little bit. Identify the degree of each monomial. So for the first one, well, degree means the highest power, okay, or sum of all the powers, sum of all the exponents. So in this case, there's only 1, 6, so our degree is 6. Let's look at the last one, 5.67. Okay, well, is there a variable there? No. So that's actually like an x to the 0, which means we have a degree of 0 for this one, degree of 0. The middle one's a little trickier. 3 times a squared times b times c cubed. Well, let's not forget that b is actually like having a b to the 1. That's a terrible one. Let's erase that. I'm going to try really hard. This is really small for me to write. B to the 1. Okay. So that's a squared, okay, times b to the 1 times c cubed. So the degree would be the sum of all of those exponents. 2 plus 1 is 3, plus 3 is 6. So that's actually a degree 6 as well, that middle one. Sample 2, rewrite each polynomial in standard form. Then identify the leading coefficient, degree, number of terms, and name the polynomial. Naming being like, is it a polynomial, is it quintic, is it quartic, such stuff like that. Okay, so first, rewrite it in standard form. Now, standard form is just the highest degree term goes first, then the next highest, then the next highest, then the next highest. So I've got 3 terms in example A here. And the first term doesn't have any variables with it. Okay, the second term has a square, third term has x to the 1. So I want to put the term with the highest degree, which is the 5x squared, so negative 5x squared. And then I want to do the next biggest term degree-wise, which is 4x to the 1, and then plus 3. Okay, I'm just ordering these by their degrees. All right, part B, let's order that by its degrees. Switch to blue for part B. 3x cubed minus 4 plus 8x to the 4th. Well, 4th is the biggest degree, so 8x 4th should go first. Then I should do cubed next, because that's the next biggest power. And then there's no squared term, there's no x term, it's just a 4, so I'll put the 4 in. All right, let's go. The next it says, find the leading coefficient. The leading coefficient. Well, the leading coefficient is just the number on the biggest degreed term. So for part A, that would be negative 5. Negative 5 would be the leading coefficient. I'm going to do LC, comma, negative 5. All right. For part B, 8 would be the biggest term. LC, comma, 8. Leading coefficient's 8. The next one, okay, so what's the degree of the entire polynomial? Well, the degree of the polynomial is, okay, the biggest power, okay, term with the biggest degree, the biggest power. In this case, this is a degree 2, because we have a 5x squared. So I'm going to put DEG, degree 2. And then for the next one, DEG, well, the highest one's a 4, so degree 4. Okay? The first one is degree 2, second one is degree 4. Then according to directions, I need to give the number of terms. Well, I'm not going to write this down, but the first one, we can see that there are 1, 2, 3 terms. Second one, there are 1, 2, 3 terms as well. And the last thing I want to do is name the polynomial. Okay, so in this one, okay, we have 3 terms. Okay, thus this would be a trinomial. Okay, this is a trinomial. It's also a quadratic. So trinomial or quadratic. And why is that? Let's scroll back up. Okay, our quadratic just means the degree is 2. Okay, but a trinomial, if we have 3 terms. So we do have 3 terms in that. 1, 2, 3. The quadratic just is because it's to degree 2. My L on the side of my paper is moving up and down with me. That's weird. All right, let's try to line that up. Okay. For the next one. This is also a trinomial because there's 3 terms. Okay, but we need to decide what to name it. Okay, as far as the degrees, well, it's a degree 4, which means if you scroll back up to the top or look back up to the top of the page in that table, that's a quartic function. Or excuse me, a quartic polynomial. Not a function because there's no f of x or something of x, no equal sign. All right, moving on. Apparently the L is just going to follow me up and down the page, so disregard that L on the left of the screen there. All right, simplify. And it gives us a trinomial, and then it gives us a, well, polynomial, because there's 4 terms or more. Simplifying is this easy. We're just adding those 2 things together. All we have to do is terms that have the same variable and powers get added together. So let's do the first one here, example 3. I see the biggest power is there's an x cubed term, and there's another one here. Okay, I'm just going to add those together. 2x cubed plus 1x cubed is simply 3x cubed. It's essentially like saying 2 apples plus 1 apple is 3 apples. Okay, you just change the number in front, change the coefficient. All right, well, next we want to put the squared term together. I only see one squared term, so it becomes 5x squared. I can't add a squared and a regular x, and I can't add a squared and a cubed. Okay, I can only add squareds with other squareds. Next, I have x terms. Okay, so 7x, and then I see a negative 1x here. So 7x plus negative 1x would be negative 6x. All right, and then are there any terms without x's? There are 2. There's a 9 and a 4. Put those together and you get 13. There it is. That's all there is to simplifying polynomials. But, of course, we'll do another example. Okay, so for example 4, the big difference here is this subtraction sign. Okay, so a subtraction sign there. All that does is just changes the sign on all these other terms. Okay, so instead of a minus 3x cubed plus 2x to the 4, blah, 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 okay, we need to make that a plus negative 3x to the 5th. We need to give this minus sign to every term. 5 terms. Minus 2x to the 4th. Okay, that sharing that negative will make that a positive 5x squared now. Make it a positive 2x, and then a negative 1. All right, now I'll just go ahead and quickly write the first ones in. All right, so now I have to go through and basically do the same thing I did before. Starting with the highest degree term, that's x to the 5th. I don't see any other ones, so I'll just start with a negative 3x to the 5th. Okay, are there any 4th terms? Yeah, there are. There's a negative 2x to the 4th and a positive 4x to the 4th. 4 apples plus negative 2 apples is positive 2x to the 4th. All right, any cubed terms? I don't see any. Okay, so we can skip cube on to squareds. There's a negative 3x squared and a 5x squared. If you add those together, you should get a 2x squared. All right, those are those terms. Are there any terms with just x to the 1? Yep, 2x. I don't see any other ones, so just plus 2x. And then I got to do the x to the 0 terms, or the terms without x's. And I see a 6, and I see a negative 1. Add those together, and you get 5. There we go. There is our simplified polynomial. We put all of the terms that can be combined together. All right, lastly, there's a little word problem. Okay, the cost of manufacturing a certain product, any product you want, can be approximated by f of x equals 3x cubed minus an 18x plus 45. Okay, x, we're being told, is the number of units of the product in hundreds. Okay, number of units in hundreds. Evaluate f of 0 and f of 200 and describe what the values represent in full sentence. Evaluate just means plug it in. You've used a function before. So let's plug in 0 to that function and see what we get. All right, so I just put 0 in where I saw x's. Okay, well, 0 cubed is 0 times 3 is 0. 18 times 0 is 0. So 0 minus 0, and then plus a 45. All right, well, we all know that if we 0 minus 0 is 0 plus 45 is 45. Okay, so plug in 0, get out 45. What does that mean? That's the number of units in hundreds. Okay, so we plugged in 0 and got out 4,500. Or excuse me, plugged in 0, 100 and got out 45. Sorry, we got out 45. As in the cost would be 45. Okay, now let's do the next one, 200. Okay, so we just got to plug 200 into all those slots. All right, and there it is. Now, I can't do that in my head because the numbers are getting big. So I went ahead and did it on a calculator, and I got the following. Okay, that's a large number, 23,996,445. So let's think about what these two answers mean. In the first one, okay, we produced 0 units of the product. And that cost us, I'm assuming, $45. Okay, they didn't give us anything as far as what the Y or what the function was spitting out. They didn't give us units, but I'm gonna say $45. The other one, we put in 200 units. So 200 and another 2 zeros, so that's 20,000. So another one, 20,000 units, and that's gonna cost us about $24 million, looks like. Okay, so just using functions. If we scroll down, there are some graphing things. We'll do this in class. Okay, so I'm not going to go through this. We'll practice with our graphing calculators for these two. But that's it for 6-1. If you have to watch a 6-2 day 1 video as well, go ahead and flip to that page in your notes and click the 6-2 link in the daily agenda or the anchor document and start there.